So before we get started on the notes, we're going to look at problem 33. So first thing we're looking at is problem 33 from 2.1. We want to apply these three transformations. Now the first one we'll apply is the horizontal stretch by a factor of 2. So the general form would be f of ax, where a is the amount we stretch or shrink it by. Horizontal, we got to make sure that whatever the value they give us is, we have to flip it. So when we plug this in, we put 1/2 in for a. So we're looking at f of 1/2 x. Now since we don't have f of x anymore, we have to replace every x in f of x with 1/2 x. So we'd still have the 8, but the x is going to become 1/2 x. We still have the square, we still have everything else. Now this here, and especially this question, it is going to ask us for the vertex, so we're going to try to keep it in vertex form. So we'll keep the parentheses, we're not going to square the 1/2 x. We'll leave it as 1/2 x squared. So that's our horizontal stretch of 2. Questions about the horizontal stretch? Now the next thing we're going to do is up 2. Our general form for vertical translations up or down would be f of x plus k. But we're not applying it to f of x anymore. We're going to apply it to our h of x. And the value of k is how far we're moving up or down, which is 2. And since we're moving up, it would be positive 2, so plus 2. Now, since we have plugged in our transformation amount, we can replace h of x with its function. So we replace h of x with the 8 parentheses 1/2 x close parentheses squared minus 6. Now, since there are no operations or anything we need to do through this function here, we can go on and drop the parentheses. And then combine like terms, telling us we have 8 times 1/2 x squared minus 4. We call it g of x, doesn't really matter. But that takes care of our transformation of up 2. Now the only thing we have left is our reflection across the y-axis. Stay on the page. The general form of it is normally f of negative x. But since we're not applying it to f of x, it's applied to g of x. We'd say g of negative x. So we're replacing every x in the function with negative x. So we'd still have the 8. We'd still have the 1/2, but now this x is going to become negative x. Now before, when we had the 1/2 x squared, we left it, we're not squaring it. But inside that parentheses, we have the 1/2 parentheses negative x parentheses. We can still simplify, we can multiply that there, still leaving it in vertex form, because that'd be negative 1/2 x squared minus 4. And that'd be the final answer, our rule for this here. And the reason we can do the 1/2 and negative x is because, again, we're trying to keep it as close to this here. We do have a value in front of x, but that's fine. As close to this vertex form as we can. This a times x minus h squared plus k. So we still kind of want that parentheses squared if there's a number inside there with it. Because the 1/2's there, we're not just going to square. We're just going to leave it as the negative 1/2 x squared. Now the only other thing we need is the vertex, our h, comma, k. What is the value of k here? -4. What is the value of h? So the vertex is the point 0, -4, 8, parentheses, -1/2 x, close parentheses, squared, -4 would be the answer for the equation. Questions on this here? Does that answer y'all's question on that one? And yes, it does have 3 steps, and we get this here. Did y'all look that one up or see what it said for this one? Or just had a question on it? Just had a question on it? Yeah. Because there are some places that will say, and I think the textbook also says, that it's just 8 times 1/2 x squared minus 4. And this is more into the context of squares being perfect squares, not perfect squares, quadratics reflecting on themselves if they're still at the y-axis. But this here is the answer I would take. I'll take either one, but that's what we end up getting. Any other questions on the homework? (17). What's the equation for 17? Just this? So the negative is in the place of a. So that tells me that there is a reflection. Because if we have a negative in place of a or b, so if a is negative or b is negative, b is inside the parentheses in front of x, a is outside the parentheses in front of x. If there are no parentheses, it's automatically outside. If it's outside, it's a reflection across the x-axis. If it's inside the parentheses, it's across the y-axis. So that negative tells me it's a reflection across the x-axis. Do we have a number besides 1 in front of our x? No, so there is no vertical stretch or shrink. Do we have a value for h? No, so there is no movement left or right. Do we have a value for k? So there is no up or down. So the only transformation being applied here is reflection across the x-axis. And that's it. So we're really looking, especially with these transformations, the values of a, h, k, and well, the book calls it a also, but I call it b in front of x inside the parentheses. If we have a value in one of those spots, a transformation is taking place. If not, there is not one. Now we're going to move on. If there are other questions, we can talk about them. I can answer them later or before we start class Monday. We're not here tomorrow. Well, y'all aren't here tomorrow. Yes. So I'm going to skip ahead. I'm going to come back to this if we have time. I want y'all to turn the page in your notes. I want you to have x-intercept form, or it should say properties of the graph of f of x equals a parentheses x minus p times x minus q. This is what we should be looking at. Yes. Oh, use these for now. So the last form that we're going to be looking at, 2-2. Okay, so yeah, you'll need to get one, so he'll need that one. So if you want to go get yours quickly. What we're looking at is this here. Now this is the last form of a quadratic we're going to look at in 2-2. So the general form is this right here, a times x minus p times x minus q. Now, I call this form x-intercept form. X-intercept form. And there's a reason we call it x-intercept form. And besides standard form is just the standard way we would write a quadratic, a parabola equation. Vertex form, we call it vertex form because it has the h and k values, which tell us what the vertex is. So we call it vertex form. X-intercept form tells us the values of x where it will cross the x-intercept, our x-intercepts. And our x-intercept, the value of y at the x-intercept will always be 0. The value of y at the x-intercept will be 0. And the x values are the value of p and q. Now, if we look at the equation, it's x minus p and x minus q. So again, just like with our values of h, if we have x minus 2, the value of p is going to be 2. If we have x plus 2, the value of p is going to be negative 2. So again, we have that kind of sign switch because of just how it's written in the standard form. Now, just like yesterday, we will find the axis of symmetry. And our axis of symmetry is given to us by the equation x is equal to p plus q over 2. So the axis of symmetry is given to us by this equation. X is equal to p plus q over 2. Now the vertex, you're going to have to add this in, is the point p plus q over 2, comma f of p plus q over 2. And as we saw yesterday with standard form, negative b over 2a was the x value of the vertex, f of negative b over 2a was the y value. So really, what is that saying? We find what p plus q over 2 is, plug it back into the function. So with the x-intercept form, we're actually finding a few things. We are still going to find the vertex of this parabola. We are going to find the axis of symmetry, and we will find the x-intercept. So we're finding one more thing. Now with this here, the axis of symmetry is going to be exactly between our two x-intercepts. It's always going to cut those in half. And the vertex, the x value of the vertex, is always going to be the same as the axis of symmetry because the axis of symmetry goes through the vertex every single time. So the big thing we need for this here is the values of p and q, and we can plug it in and find this here. The value of a is still going to tell us if it opens up or down. So I do have it up here on the whiteboard too, if you need that. And I will be rewriting some of it up here as we go through. Now, when we look at this here, we're told that the equation in standard form of x-intercept form is a times x minus p times x minus q. And just like before, we still want to find the vertex. And the axis of symmetry. But we're also going to find the x-intercepts. Now the x-intercepts are the point p comma 0 and q comma 0. The vertex in the general form is P plus Q over 2, comma, F of P plus Q over 2. And the axis of symmetry is given to us by the equation x equals P plus Q over 2. So these are just the general forms. And out of all three of these here, we know that the same term, the same variable that shows up time and time again in all three spots is P and Q. So at this point here, it would be good for us to actually say what P and Q are. Well, A, P, Q. What is our value of A? -2. What is the value of P? -3. So it is 3, but because we have x plus 3 inside the parentheses, standard form is x minus P. So the only way I can go from x minus P to x plus 3 is if the value of P is negative. Because really what we're looking at is not really x plus 3, it's x minus -3. We don't leave minus negative, we just turn it into a plus. So P is -3. Q would be 1. Would it be positive or negative? Positive. X minus 1, x minus Q. So Q is just our 1. Because there is no sign change taking place from x minus Q to x minus 1, so Q is just 1. Questions on how we found A, P, Q? I will tell you this here, whichever one we determine as P and Q really doesn't make a difference. Because we could have set Q as -3 and P as 1. As long as we have one as one of them as the other, we're good. Now the first calculation we need to do is P plus Q over 2. Now for this here we said P is -3 and Q is 1. So P plus Q over 2 would be -3 plus 1 over 2. Now at this point here, we can plug this all into a calculator and let it do it for us, or we can do it by hand. -3 plus 1 is indeed -2 over 2, which is -1. So P plus Q over 2 is -1. So we can plug it into those two spots, because in the vertex P plus Q over 2, we have that value, we can plug it in. The vertex, or not the vertex, the axis of symmetry, x equals P plus Q over 2. So for this here, x equals -1. Now the f of P plus Q over 2. So really all this is saying is we want to evaluate f of -1. So our function, -2 times x plus 3, well, we're going to replace that x with -1, times x minus 1. Now we could put that 1 in parentheses if we want, that -1 in parentheses. We can. We don't need it, but we can. Adding it's not going to hurt anything. It will still give us the same answer. And again, at this point here, we can calculate these values. We're going to do what's inside the parentheses first. So our first one, -1 plus 3 is 2. Our second set of parentheses, -1 minus 1, is going to be -2. So what we're left with is -2 times 2 times -2. So we're multiplying three numbers together, yes? Let's look at signs first. We have a negative times a positive, which would be a negative. And then we're multiplying it by a negative, yes? Negative times a negative is a... So whatever the number is going to be positive, yes? Let's look at the numbers. 2 times 2 times 2, 8. So the y value of the vertex is 8. Because -2 times 2 would indeed be negative 4, and negative 4 times negative 2 would be positive 8. So the vertex is the point negative 1, 8. Questions on how we found the vertex or axis of symmetry? Have we found everything we needed? Now we need to find the x-intercepts, yes? Really, we could have started there and found them first. Because our x-intercepts are the points, what? P, comma, 0, and Q, comma, 0, yes? Well, the y values are both 0, no matter what P and Q are. So that's what it means across the x-intercept. The x-axis, the y value has to be 0, yes? What's our value of P? Negative 3. So one of the x-intercepts is the point negative 3, 0. What's our value of Q? Q is just 1, because we got it at the start, yes? So that's 1, 0. Could we have plugged in the x-intercepts before we did anything else? Yeah, as soon as we found the P and Q, we could have found those first. Questions on this here? Now, especially on the homework, this is all I'm going to ask you to do, because, again, if we wanted to graph this and see the graph of it, the graphing calculator will do that. We hit y equals, type the function in, hit the button that says graph, and it will tell us the graph. If we were doing this by hand and didn't have a graphing calculator, we can use this information here. The vertex is the point negative 1, 8. That's our vertex. Now, because the value of A is negative, we know it's going to open down. It's going to go down. Now, the nice thing about the x-intercepts is we know that this graph is also going to cross at negative 3, 0, and 1, 0. And that there would be our axis of symmetry. So we know what the graph, the equation looks like. But the main thing I'm looking for is being able to find the vertex, axis of symmetry, and x-intercepts for these here. Questions on this here? Let's look at this next one. Negative 1/3 times x minus 4 times x plus 2. What is our value of A? Negative 1/3. What's the value of P? Positive 4. And Q is negative 2. Because again, we're lining it up to our A times x minus P times x minus Q. The x minus 4 is going to give us a value of positive 4. X plus 2 is going to give us a value of negative 2. Vertex. Axis of symmetry. And x intercepts. All right. We didn't start here, but might as well. X-intercepts. We know that the y values of the x-intercepts have to be 0. What's the value of P? 4. So one of the x-intercepts is the point 4, 0. The other x-intercept is the point negative 2, 0, because Q is negative 2. We have the x-intercepts. Now to find the vertex and axis of symmetry, we have to calculate what? First off, P plus Q over 2. Our value of P is 4, and the value of Q is negative 2, yes? And again, at this point here, we could stick the whole thing in the calculator, let it do it for us. If we did this by hand, negative 4 plus, or not negative 4, 4 plus negative 2 is 2. 2 divided by 2 is 1. Now, I said earlier, it really doesn't matter which one, the 4 and negative 2 we define as P and which one we define as Q, yes? As we did here, 4 plus negative 2 is 2, yes? Say I flipped it and I said that P is negative 2 and Q is 4. We would instead have negative 2 plus 4, yes? Well, what is negative 2 plus 4? It's just still. So even if we switched it, it's still 2. That's the nice thing about addition. No matter how we add two things, we get the same number. So that really is why P and Q are really interchangeable. Now, we plug the value P plus Q over 2 in its two spots, the X value of the vertex and our axis of symmetry. Now the last thing to do is to find what? The Y value of the vertex, yes? Which means we take this value of 1 and plug it into the function. So our F of 1 would be negative 1/3 times 1 minus 4 times 1 plus 2. And yes, at this point here, 30xs, the yellow calculator, you can stick that whole thing in it just like it is right there as we have it written, and it will do it for you just fine. If we do this by hand, 1 minus 4 is negative 3. 1 plus 2 is 3. Now, they were kind of nice with this here, especially with this fraction. We don't necessarily have to have integer answers every single time. But if we look at this here, we have a negative times a negative times a positive. Well, our negative times a negative would be a positive. Positive times a positive is still positive. 1/3 times 3 is 1. Because 1/3 times 3 is 3/3, which is 1. And 1 times 3 is 3. It's negative 1/3 times 3 times 3. Well, it does help if I say that first 3 is negative. But we get 3, telling us that the Y value of the vertex is 3. And that's it. Questions on this here? Huh? So how would it graph? So what we would do first is a point, that 0.13, we would go with it first. Now, since A is negative, we know it should open down from there, and we can plot the points. Now, 1/3 times X, it was minus 3 times X, I'm trying to remember if I got the sides right, X minus 4 at X plus 2, yes? Minus 4 helps if I'm actually looking at the equation graph. Second graph, second table. So we said the vertex was the point 1,3, yes? Is that point listed in our table? Yes. And if we look 1 unit to the left, when X is 0, the value of Y is 8/3, yes? 1 unit to the right. So we're looking at, bless you, 2. Is the Y value the same? Yeah, they're both 8/3. We said one of the x-intercepts was at the point -2, 0, yes? We said the other x-intercept was at the point what? 4, 0, yes? It does agree. So our graph is this here, and this is how it looks. So again, we're able to use the equation. We know which parts are which. We can verify with the graph. The graphing calculator does it. Makes sense? Questions on this here? I believe we have 2 left. Yes? 2 left. Let's look at this one here. I need to go back and pull those graphs off of there so you have a little more room. A, P, Q. Okay. Looking at this here, what's the value of APQ? A is -1, yes. P is -1, and Q is -5. So let's start with the x-intercepts, because our 2 x-intercepts are P, 0 and Q, 0. So they would be the points -1, 0, and -5, 0. Just like we said already, P and Q are really, it just has to be either -1 or -5 in this case. And even if we flipped them, it would just say that it's -5, 0, and -1, 0. We still have the 2 points listed, it's just in a different order. That doesn't matter, as long as we have the 2 x-intercepts listed. For vertex and axis symmetry, we need to calculate P plus Q over 2. So in this case, we'd have -1 plus -5 over 2, yes? -1 plus -5 over 2 is indeed -3. Because -1 plus -5 is -6. And -6 divided by 2 is -3. So we get the x value of the vertex, and we get the equation for the axis of symmetry, x equals -3. Now the last thing we need to do is plug it into the function f of -3. So we have -3 plus 1 times -3 plus 5. Again, if we want to, we can type this whole thing into the calculator, graphing or 30xs, and it will tell us what it is. Especially at this point, if you don't feel confident with this many negatives in the equation, go and type it in. Because if we do this here, -3 plus 1 is going to be -2. -2 times 2 is -2, and then our negative in front would give us 4. Because our -1 times -2 would be +2. 2 times 2 is 4. The y value of the vertex is 4. That's it. Questions on this here? Do we need to see another example of this here? Feel good? Y'all feel good with this here? Yes? So if you already did this one or getting the answers, the vertex would be the point 4. Goes 2, -2, 2, 1. Axis of symmetry would be x is equal to 4. And our x-intercept should be the point 6, 0, and 2, 0. -2, 2, so -4. Yep. Ah, -1. Sorry. We get this here. for -1 is our vertex. And then 6, 0, 6, 0, 2, 0 are our x-intercepts. Now the point 0, 3 is not an x-intercept. That's a y-intercept. Because when the value of x is 0, that's where it crosses the y-axis. Now it could cross at 0, 0, which would be an x and y-intercept. But that is it. Now, yes, there is no homework sheet attached. That's because trying to save on paper, I printed it. So there's an extra one in there. 4. So you'll work on this here. I will post it in Google Classroom. So if you do lose this, that is another place to get one.